Hello, and welcome to NASA's Summer of Innovation. I'm here to discuss the activity, How Does Earth's Energy Budget Relate to Polar Ice? The activity is located within the theme Earth and Space Science, Unit Climate and Seasons, Lesson Climate. The activity link will take you to a lesson page on the MyNASA Data website shown here. The object of the lesson is to use real climate data from a live server to produce maps of polar ice worldwide and maps of atmospheric temperature. Polar ice coverage on Earth is subject to seasonal variations based on climatic factors. In the winter, polar ice extends more toward the equatorial region. In the summer, polar ice retreats to more polar latitudes. By comparing the maps of polar ice and air temperature side by side, students determine the relationship between the Earth's energy budget and the movement of polar ice throughout the year. Scroll through the main climate lesson to access the activity. The activity is the first of 4 activities. Before beginning, be sure students are familiar with accessing the internet if you choose to have them access it during the activity. Also be sure students can locate places by latitude and longitude. In addition, students will need a strong understanding of Earth's energy budget. If you need to review Earth's energy budget with students, the lesson contains some excellent resources to help you. The lesson purpose states to use satellite data to understand how the net flux of the radiation budget relates to the amount of polar ice present in the northern hemisphere. In other words, students compare atmospheric temperature maps to polar ice maps and draw conclusions related to Earth's energy budget. Now let's do a quick content review. The lesson contains links to a glossary. The first term to review is flux, or net flux. Flux is the rate of transfer of a fluid, particles, or energy across a unit area. In the atmosphere, this can be air, a particle pollutant, or aerosol, light energy, or heat energy. To simplify the definition specific to the lesson, flux is the transfer of energy from the Sun to Earth. Net flux is the total heat energy transfer from the Sun to the atmosphere of Earth. Next, students need to understand radiation. Solar radiation is responsible for the flux of heat on Earth, or how much energy is transferred from the Sun to Earth. Solar radiation travels as electromagnetic waves that may be reflected or absorbed by substances. Selecting the More About Electromagnetic Waves link within the radiation section of the glossary takes you to some excellent resources on electromagnetic radiation and the electromagnetic spectrum. Net radiation is the amount of radiation added to a surface. Net radiation takes into account all wavelengths, subtracting outgoing radiation from the incoming radiation. On the definition page, select the Visualization of Net Radiation link to view an excellent visualization on solar radiation and how it is absorbed over time. Notice the migration or movement of net radiation from north to south as the seasons progress. This is a great way to assess student understanding of Earth's tilt on its axis and the causes of seasons. Ask students to observe what happens in the visualization over time. As the Earth revolves around the Sun during summer in the northern hemisphere, the concentration of net radiation is more northward. At the same time, the southern hemisphere experiences winter. This is the reason seasons are opposite in the northern and southern hemispheres. You can pause the visualization to demonstrate this information. Students, try asking for a student volunteer to manipulate the visualization to show summer in the southern hemisphere. Finally, students need a thorough understanding of Earth's energy budget, which is a balance between incoming and outgoing energy. The diagram demonstrates absorption and reflection of radiation from land surfaces and the atmosphere. The lesson link on the definition page takes you to a NASA background reading perfect for students to use as a reference or reading assignment. Thank you for joining us as we explore together in NASA's Summer of Innovation.